In the previous sessions, we have seen arithmetic progression, we have seen arithmetic series. Now let's look at arithmetic mean. Arithmetic mean is a measure of central tendency that is calculated by adding up the terms and dividing by the number of terms. So let's take it step by step. Given two numbers, 24 and 18, we know the mean is 24 plus 18 by 2, which is equal to 21. I'm writing mean, but specifically what we mean here is arithmetic mean. Again, given two numbers 0 and -6, the arithmetic mean is 0 minus 6 by 2, which is -3. Given two numbers -12 minus 18, we have the arithmetic mean as -12 minus 18 by 2, which is equal to -15. So what does this mean? Basically, what we get by evaluating the mean is the fact that 24, 21 in between and 18 is an arithmetic progression. Similarly, 0, -3, -6 is an arithmetic progression. And similarly, -12, -15, -18 is an arithmetic progression. Now, what happens if we have three numbers? So, given three numbers, 2, 6, and 10, means are 2 plus 6 by 2, which is equal to 4, and 6 plus 10 by 2, which is equal to 8. So, here again, 2, 4, 6, 8, 10. 2, 4, 6, 8, 10 is an arithmetic progression. In general, mean of n terms of an arithmetic progression, as we have seen, is the sum of the terms divided by the number of terms. So S sub n is a series up to n divided by the number of terms, which is equal to the summation from k equal to 1 to n of a sub k divided by n. So if we take this example, then the mean is 2 plus 4 plus 6 plus 8 plus 10 divided by the number of terms, that is 5, which gives us 6. If every time we are given, say, 10 terms in a arithmetic progression and we are asked to calculate the mean, doesn't make sense to start adding up all the numbers. So what do? We have to realize that arithmetic sequence has symmetry. So here if you notice, 2 plus 10, first term and the last term, the sum is 12. 4 plus 8 is again 12. So, which means we can use this symmetry to figure out the mean of n consecutive terms. So, 2 plus 10 by 2, 4 plus 8 by 2 is equal to 6. And as we have seen, mean is 6. So, what this means is we can take the first term in an arithmetic progression, we can take the last term in the arithmetic progression, add them up and divide by 2 instead of adding up all of them. For that matter, we can take any two terms provided they are the symmetric to each other. So if say for example 4 and 8, 4 is the second term from left, 8 is the second term from the right. So arithmetic mean is equal to a plus a sub n by 2. So here we are taking a as the first term, a sub n as the last term, divide by 2. We don't have to bother with any of the intermediate terms if we know that sequence is an arithmetic progression. Let's look at this arithmetic progression. Mean of this progression is 3 plus 13 divided by 2 or 5 plus 11 by 2 or 7 plus 9 by 2. In each case, it will be equal to 8. Mean of a finite arithmetic progression is given by, because of the symmetricity, we have a sub I plus a sub n plus 1 minus I by 2, where I is in 1, 2, 3, 4, dot, 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 floor of n by 2. Because the index has to be a natural number, but if there are odd numbers, we may end up with fractions. To avoid those fractions, we take it as floor of n by 2. So here we have 6 terms. So 6 by 2 is 3, no problem. But if we had 5 terms, then we would have 5 by 2, which is 2.5, which doesn't make sense. It's not a natural number. So we take it as floor of 2.5, that is 2. I'm writing what we have learned already in formal notation. Now, if we are going to use this formula to figure out the mean, if I is equal to 1, then what will be our expression? A sub I, that is A sub 1 plus A sub n plus 1 minus I. I is 1. So 1 minus 1 is 0. So A sub n. So we have A1 plus A sub n by 2. Now, if we take I is equal to 2, then what happens? A sub 2 plus A sub n plus 1 minus 2 by 2, which is equal to A sub 2 plus A sub n minus 1 by 2. So, in general, the mean would be any symmetric terms added together and divided by 2. Now, here for each of these, I'm putting a single I'm using a single letter M, because they are all going to be equal in case of arithmetic progression. Given an infinite arithmetic progression, we can take intermediate consecutive terms to form an arithmetic progression. So if we have A1, A2, A3, A4, A5, A6, dot, 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 dot as an AP, then A2, A3, A4, A5 is an AP. A5, A6, A7, A8 is an AP. Any non-consecutive terms of an arithmetic progression does not form an arithmetic progression unless the jumps are regular. So again, in A1, A2, A3, A4, A5, A6, dot, 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 dot being an AP, A sub 1, A sub 2, A sub 4, A sub 5, A sub 7, this is not an AP. Why? Because here we are starting with A sub 1, the next term is A sub 2, but the next one is A sub 4. That means the difference between these two is 2D. Here it is D. Here it is again D. And here again it is 2D. So, that means there is no common difference. But A1, A4, A7, A10 is an AP. Because again, if you notice, the difference between these two terms is 3D. Between these two is again 3D. And here also it is 3D. So you have a common difference between these terms. So it forms an AP. So given an infinite sequence or infinite arithmetic progression, we can't figure out the summation or the value for the series up to infinity. But what we can do is figure out the sum of n number of terms starting from a particular term in the infinite sequence and up to a particular term. So that was arithmetic mean. In the next session, we will look at some exercise on arithmetic progression, arithmetic series, and arithmetic mean. Now, if you found this session useful, don't forget to like, share, and subscribe. Questions, suggestions, and comments are always welcome. Thanks for watching. See you in the next session. That's it for now.